The devices that we produce today are complex, and their supply chains are equally as complex. And because of that, it can lead to delays in deliveries, and that can be really limiting to our customers' business. That's why we believe that if we can employ a 3D process, we can start to get greater reliability. And the way that we've done it here is to be able to provide the scale so that that growth that is expected by our customers can be delivered by Orchid in a fashion that's reliable.
What has led us to this point where supply chains have gotten very complicated, and now we have a lot of customers asking us, how do we kind of revert that back to being something a lot more manageable?
Part of that is you think about the evolution of the devices, right? And a lot of them started out without these complex lattice structures for ingrowth or on-growth. And so as a device that's strictly starting as a casting and then going into a finishing operation, that's where everything started. And then our customers began to use these additional treatments, and it just adds a layer of complexity. It's another stop in the value chain. And a lot of our customers, now that they're seeing that this rate of adoption that's going from cemented to cementless, they're trying to figure out, does the supply chain have adequate capacity to service that? So now that we have 3D, we can almost plan backwards with the end in mind. And we can say, okay, we want this specific design. We can do it in a way where we're now predicting what the demand might look like instead of reacting to it as it's been in this rapid growth phase. So that's why we made the investment that we have. Scale, reliability, and ultimately to deliver our customers a sufficient amount of product that does not limit their growth potential.
So one of the big differences in going from a 3D modality versus a forming or a casting modality is that there's not as much upfront time required to see what a device is going to look like. So we can iterate very quickly on a 3D printing device, which not only speeds up the manufacturing, but also can allow for some more design freedom upfront in the process instead of having to go through multiple iterations that each take a significant length of time. Traditional large joint supply chains often involve anywhere from 10, 15, maybe 20 steps to get to a finished device, especially if it's a cementless device. With 3D printing, we can pare that down and have it be really less than 10 major steps to complete the same device and get it to a finished state.